So the last set of exponential, or rather transcendental function differentiation formulas. So you have exponential function differentiation. Okay. So if we have constant raised to the power of a function of x, so a raised to the power of u, take note, a is a constant and u is a function of x. So it's equal to, you copy the given function and then multiply it with the ln of the base, okay, the constant, and then multiply it with the derivative of the power, okay, or derivative of u with respect to x. And then if the base is the Euler's number, so basically e raised to the power of u, okay, and then multiply it with the derivative of u with respect to x. So if you compare the two, there's no more ln of a. Okay, it's actually, this is just derived from the 21, no? So ln of a, meaning a is Euler's number. So ln of e, and ln of e is just equal to 1. Okay, so ln of e, okay, that can be written as log. So log, okay, of e to the base e. So recall, no, in our exponential function to logarithmic function transformation, okay, we need to look for the power that we're going to raise e to, no, so that we'll get, no, this number. So e must be, of course, raised to a power of 1 to get this number, no, so that will be equal to e. Okay, so that's why this is equal to 1. So it's basically just from that formula above. All right. So for example, okay, y is equal to 4 raised to the power of 2x. So this is an exponential function, because the base is a constant and the power is a function of x. So if we follow that format above, so that u be equal to 2x, and then a is equal to 4. Okay, so a is 4 and u is 2x. So to solve for its derivative, okay, so we simply, okay, copy the given and then multiply with ln of the base and then multiply it further with the derivative of the power. Okay, so copy the given. So 4 raised to the power of 2x times natural log of a, so natural log of 4, and then multiply it with, okay, the derivative of the u, which is 2x. Okay, so derivative of 2x is 2, so it's 4 raised to the power of 2x times ln of 4 times 2. Okay, take note that we cannot multiply 4 raised to the power of 2x and ln of 4 because it's exponential, it's an exponential function. Okay, so we can, however, multiply this constant 2 and ln of 4. So it's 2 times ln of 4, or using one of the properties of logarithm. Okay, if you can look at your list of formulas. Okay, I'm not sure of the letters used, no, in the list of formulas, but it's basically a constant multiplied by log of any number. Okay, let's say log of u to the base b. So you are going to put the p as a power, no, to the u here. So it's going to be log of u raised to the power of b to the base b. So it's one of the properties, no, of logarithm. Or if it's a natural log where the base is e, so it's going to be ln of u. Okay, so you can write this as ln of u raised to the power of b. So meaning 2 times ln of 4 can be written as ln of 4, no, raised to the power of 2. And then 4 squared is 16. So 4 raised to the power of 2x times ln of 16. So you write the exponential function first before the logarithmic no function. So this is the final answer. Okay. So another example is if the base is e, and let's say the u is a trigonometric no function. So let u be equal to sine of x. So to get the first derivative, you copy the given and then multiply it with the derivative no, of the power. So meaning times the derivative of sine of x. And derivative of sine of x is cosine of x. So when you write exponential and trigonometric functions, okay, so you write first the exponential before the trigonometric so that you don't need to put a center dot or parenthesis no, for the multiplication. Okay, so another example, last example. Okay, so let's say we combine, okay, um, uh, okay, so for example, uh, e to the power of x, no, times e to the power of ln of x. All right. So both are e raised to the power of u, no, written as e to the raised power of u. You can use the product rule. Okay. Or since they are being multiplied and they have a common base, so we use the laws of exponents no, in simplifying this function. So do not solve for the derivative yet. So transform sa nato so that we can have a shorter solution. Okay, instead of using the product rule, so you multiply first the two. Okay, so it's e raised to the power of, no, so if you have a common base, say m and n, so you copy the common base and then add the exponents. Okay, so meaning x plus ln x. All right, so it's equal to y pa, no? And then you solve na for the derivative, okay, where the u here is x plus ln x. Okay, so according to D2022, no, derivative of e to the power of u is just e to the power of u times the derivative of u. So you copy the given. So e raised to the power of x plus ln x, and then multiply it with the derivative of u, so derivative of x plus ln x. So derivative of x is just 1, right? And then plus derivative of ln x, okay, it's using logarithmic functions differentiation. It's d 19, okay, we're in the derivative of ln x. So let me just put it here, okay. So this can be solved using d19, okay. Derivative of ln u is 1 over u times the derivative of u with respect to x. So 1 over u times derivative of x with respect to x. So just copy this, and then 1 plus the derivative of ln x is 1 over u. So our u here is x. That's 1 over x. Okay, times the derivative of u with respect to x. So derivative of x with respect to x is just equal to 1. Okay, or that's e raised to the power of x plus ln x, and then you multiply it to 1 plus 1 over x. Okay, so you can have this as the final answer, or you can also combine 1 and 1 over x to make it into um just a single no fraction, or it's not necessary actually. So you can have this as your final answer. All right, so that's for the exponentiation function differentiation.